There are some rules that we need to consider in order to determine whether the compound are aromatic or anti-aromatic. Anti-aromatic, or it is non-aromatic. Okay, so there are some criteria that we need to follow in order to determine whether the compound is aromatic, anti-aromatic, or non-aromatic. So it needs to fulfill all these four criteria in order to determine the aromaticity of the aromatic compound. The first one is it should be a cyclic compound. Second one, it should be planar. Third one, it should be conjugated, meaning that the electron can be delocalized in the structure. And the last one is Huckel's rule. Alright, so this determination or this criteria can be determined following the aromaticity rules. So in the aromaticity, there are Huckel's rule that have formula for n plus 2. The n here can be any integer ranging from 1, 0, 1, 2, 3, and so on and so forth. So for the benzene, it has 3 double bond and it has 6 pi electron. So what does it mean by 6 pi electron and the Huckel's rule? So following the Huckel's rule, we try to substitute the number of n here. You can try to put 0, 1, 2, 3, or 4. You should get the value for 4n plus 2 is either 2, 6, 10, or 14. That can be said that the structure is aromatic. Okay, so example here we substitute n equals to 1 to the formula. So we have 4n plus 2, we have 6. Okay, meaning that 6 pi electron in the benzene ring. So benzene is stable and the electron are delocalized, and so it's follow criteria number 4, which is following Huckel's rule. And benzene, it is cyclic, planar, whereby it has 1 to 0 degree angle, and all the electron can be delocalized, or you can say that conjugated. For any aromatic compound that does not follow the 4 criteria to determine the aromaticity, it is called anti-aromatic. For example, cyclooctatetraene, it is planar, cyclic molecule, but it does not follow Huckel's rule, which is 4n plus 2. So it is called anti-aromatic, that have a less stability compared to aromatic. For the anti-aromatic, it has 4n pi electron. For example, cyclooctatetraene, it has 4 bonds, 4 double bonds here, and it has 8 pi electron. To get this 8 pi electron, we use the formula for n. So with n equals to 2, you will get 8 pi electron. So it means that it does not follow 4n plus 2, which is Huckel's rule. So cyclooctatetraene is anti-aromatic. Second example, cyclobutadiene. It is planar, cyclic, and conjugated, but it does not follow Huckel's rule. It has 2 double bonds here, and it has 4 pi electron. So it can have we can have n equals to 1 and substitute into 4n, and we can get 4 pi electron. So cyclobutadiene is also anti-aromatic. Because it is anti-aromatic and less stable, it behaves like alkenes. Cyclobutadiene is so unstable that it dimerizes at low temperature. For cyclooctatetraene, it has 4 double bonds. It will react with Br2, KMnO4, and HCl acid, the same like if it alkenes molecule. We know that benzene will undergo substitution reaction rather than addition reaction. So the first substitution reaction is halogenation. Benzene's pi electron can participate as a Lewis base, which is electron donor, and it will react with a Lewis acid, which acts as a electron acceptor. The product is formed by loss of a proton, which is replaced by bromine. So the use of FeBr3 is as a catalyst to polarize the bromine reagent. So we will get bromobenzene as a halogenation reaction between benzene and bromine with the presence of catalyst. Benzene also can undergo nitration reaction, whereby the combination of nitric acid and sulfuric acid will produce nitronium ion. So the reaction with benzene and nitronium ion will produce nitrobenzene as the final product. Benzene can also undergo sulfonation. In sulfonation, the mixture of sulfuric acid and sulfur trioxide will give SO3H cation. So SO3H will be substituted at the benzene ring when it undergo sulfonation reaction. For the alkylation of aromatic ring, benzene can undergo the so-called the Friedel-Crafts reaction, whereby there will be the presence of alkyl halide and the presence of aluminium chloride that are used to promote the formation of carbocation from the alkyl halide. So with the help of aluminium chloride, the CH3CH2 carbocation will produce, and benzene will react with the carbocation in order to get a substitution reaction product. Lastly, Benzene can undergo acylation of aromatic rings, whereby this is acid chloride that have a general formula RC double bond OCl. So this part will be substituted to the benzene ring with the presence of aluminium chloride. When benzene undergo Friedel-Crafts alkylation with the presence of alkyl halide and aluminium chloride, there will be formation of alkyl benzene. The alkyl benzene can further undergo oxidation reaction with the presence of KMnO4 in acidic condition, and we will get the final product of oxidation of alkyl benzene, which is benzoic acid.